I'd probably agree that the data structures and algorithms learning objective LO4 is probably easier than LO3, possibly even easier than LO2. And then LO5, I think, is the most difficult one. But like I said last time, I don't push you too hard in LO5. As long as you get a good, at least a surface level understanding of these concepts, this concept of message passing and event based architectures, I'm fine with that. With LO2 and LO3 and LO4, I expect a much deeper understanding. Nice. Easiest of the whole semester? Easier than LO1? Well, that's probably true too. LO1's definitely easier, but at that time. Um, Wait, no, that's backwards though from what you're saying. Easiest for sure. Yeah, right. LO1 is, I would argue, is easier, but at this point in the semester, you're so much more experienced that this one should feel easier. LO1, you're first learning what stack and heap is and trying to figure out what Scala is still. At this point in the semester, yeah, it's not bad. But yeah, with all these comments, maybe I should make LO4 harder next semester. I mean, we can always go deeper into data structures. Struggling so much on making edges on Maze Runner. I updated the doc a little bit. There was something I realized was fairly confusing. So if you haven't seen the update that I made yesterday, I had a few questions in office hours. I'm like, yeah, where do I explain that? So I updated the doc with this paragraph right here, trying to go from that map, that list of lists, which I call a map, not to be confused with the key value pair map, but the like a game map. That list of lists, getting the right values out of that thing can be a little tricky. But if you think of this, if you do map.apply of y.apply of x, you can get any tile at that xy. So as you're reading all the tiles, as you're looping through this list of lists, you're iterating through each row and then each value in each row in a nested loop. And then each time you get a tile, if it's passable, certainly if it's passable, you want to create a node for that. If it's not passable, I still create nodes for them personally, but you don't have to because they won't have any connections. But once you have a tile that's passable, you need to look in all four cardinal directions and check if those tiles are passable. And if the other tile is also passable, add an edge between those two nodes. So you have to look at x plus 1, x minus 1, y plus 1, y minus 1, and you can do this to access each of those tiles. If they're both passable, add an edge. And the important thing there is to remember how you're computing all the IDs for each node. So you should have some formula going from XY to an ID, and ideally from an ID back to XY as well. Here's an ID, what's the X value? Here's an ID, what's the Y value? Those are two helper methods I like. And here's an X and a Y, what's the ID for this? And have a one-to-one mapping from coordinates to node IDs. And then you can add the edge saying, okay, this tile at this XY is passable. I need an edge between these two nodes. At this XY and this XY, give me the IDs, and then I can add the edge. So however you choose, and that's the one thing that's intentionally not talked about at all in this document, is how to generate your IDs, how to manage all your IDs. That's completely up to you. But you should have some function, some way of going from an XY to an ID, if that's deterministic. That'll make it a lot easier for you. The update helped. Good. I got that question in office hours. I'm like, yeah, how would you know that? It's implied, like if you dig through all the code that I give you, you could figure it out, but it that shouldn't be as much of a mystery as I was making it to be. Of how to use that list of lists, what the structure is of that list of lists. Andrew Paul, when do you think we can schedule AO2 interviews for those of you who are on me for AO2 interviews? Application objective. Oh, right. Application objective to interview makeups. Those should be happening soon, right? We just hit the makeup deadline, so we'll get those processed in get some AO2 interviews. Next week, I plan on doing a lot of interviews too. As I get caught up, I'm in the middle of 199, my 199 module. Over this weekend, I'm going to finish all my content, upload it all, and then 442, 116 get all my attention again. And I want to get caught up on friggin' everything. And I don't have any more lecture questions, no more homeworks to release, so it's all about getting caught up with grading. Shoot. Man, that 10 minutes goes by fast. If we didn't pass LO3 interview and didn't get a makeup, will there be an opportunity to make it up? Yeah, the LO3 interview, yeah, there will be makeup opportunities. As long as you're caught up for the makeup opportunities for interviews, you got to be caught up on your lecture questions. If you want a second chance at an interview, you got to be showing us that you're keeping up with stuff. We're not just going to keep giving you makeup interviews if you're not showing any signs of life on your end. So with LO3, if you need the makeup interview, get doing your lecture questions, and then we'll start reaching out to you. LO1 interviews. Yeah, there are some students who still need LO1s. Everyone with LO1 is on me, so I'll probably be reaching out next week to anyone who still needs LO1 interviews. 199 is interesting. Nice, thank you. I like it too. I think next week is more interesting than this week. This week's a lot of math and a lot of, here's hashing, here's encryption. Next week we're going to go into the browser console and actually break websites and do some more hands-on applications. All right, let's. Where the hell am I? Get this. There we go. There's my mouse on the right screen. And if I do this, I'm on IntelliJ. It's the right IntelliJ this time. And let's do this. So today we're going to look at 2 example programs that use actors. I'm just going to talk you through them and talk about how they're designed and how we use actors. So Monday and Wednesday we saw very simple actor examples, just showing you this is what actors are, this is what they can do. They can pass messages to communicate. But we haven't really seen a more interesting application, I suppose. So we're going to see a few sample programs today, and I'll just walk you through. Through what these programs do. What's up, Mango Mutiny? Yeah, 199. I don't want to talk too much about 199 in this though, but I have comments. I think it's fun. 199 is kind of like a topic potpourri. We just explore a whole bunch of computer science topics. I think it's fun. So the lecture question today, you're going to code an alarm, and you should be grateful the LQ53 last semester, it got a bit out of hand, and it turned out to be one of the toughest lecture questions of the semester. I was thinking of turning it into a homework. I still might do that someday, making it a bit bigger and then turn it into full homework, but it's certainly not worthy of a lecture question. It's way too much. So I softened it with this alarm actor thing, which is going to be much easier. The other one was, I don't know. I don't want to talk. I will talk about it because it was actually to take one of the examples that I'm going to show you and expand on it. So we got a better question this time. Alarm actor, you're going to create this actor that that accepts messages or reacts to messages of type set alarm and alarm. Set alarm takes a double and a string, which should be interpreted as sound this alarm, like remind me of this message after this many seconds. So if I say set an alarm for 5 seconds, and when 5 seconds is up, tell me, I don't know what you would set an alarm for 5 seconds. Tell me, set an alarm for 5 minutes, and when 5 minutes are up, that means my noodles are done cooking, is the intent here. And then alarm, which is going to be sent from your alarm actor back to the sender who set the alarm, notifying, hey, your noodles are done. This is what we want to build here. So we certainly have this aspect of time that we have to consider, which is common with event-based architectures. The concept of time is very visible, very relevant in our programs now. So when you get that message of type set alarm, where am I looking? Set alarm. After this many seconds, whatever the double is in the set alarm message, which again, purposely intentionally not named any of these variables, they're not named in the description. After this many seconds, send an alarm message with this string that was sent back to the sender who set the alarm. So the one big thing that we need in today's lecture is how to delay a message, which will be in the second example that I show. And then test it. Testing, you have to make sure that you're getting that message at the appropriate time. Now, we do have some variance here, and you're going to see this in the homework as well. There's a lot of variance, and I mentioned this Wednesday as well. There's a lot of variance here, so you can be pretty generous in your test cases. Don't expect that message to be arriving exactly to the millisecond when you expect it to. Make sure you have some lenience, some variance, kind of like we do with doubles when we compare two doubles, but make sure it's a good, decent amount. So with this, as long as you're within 1 second in your testing, you're going to be fine. So if you say, set this alarm for 2 seconds, and it's anywhere between 1 and 3 seconds, well, a little bit, it's going to be fine in AutoLab for my incorrect solutions. My incorrect solutions are off by a minimum of 1 second. I have 2 test cases that are off by 1 second each. So in your testing, you do have to be aware of time, but don't make it so strict that you're not going to pass a correct solution. And you'll know this when you write your test. If your bounds are too tight, if you're expecting it within like a 10 millisecond window, you're going to fail your own test. You're going to run your test and it's going to fail on your code. But if you give it like a 100 millisecond window, you're probably going to be passing. Give it a 2 second window, then you're going to fail on AutoLab. So just be aware of that, of how much variance to allow. And this is the same I mentioned it's the same in the clicker. If you wait a full second and you're expecting 100 gold per second, you wait 1 second, don't check and make sure your gold is exactly 100. Give yourself some variance. Say if it's between 80 and 120, then we'll call it okay. Things get a lot more kind of wishy-washy, I guess. I'm lacking a better phrase there. Things get a bit more, there's a lot more variance when we have programs like this. They have to work in real time, and we're trying to wait a real time amount of time. There are ways to test that and be very precise, but the way we're testing now, we're gonna be a little loose and fast with our testing. So let's see a couple of examples. Let's do the first one. For this one, I think I only have one slide explaining this. For this one, we're going to simulate traders buying and selling, well, not even selling, but buying stocks. This would be the start of a stock market simulation, which, hell, this one might turn into a full-blown homework assignment someday, too. We certainly can turn this one into a homework assignment. I think it'd be a pretty interesting one, too. Simulating trades, and we could even get to the point where we're automating the trading and having trading algorithms trying to make money off of these stock prices. Something we could do. Today we're just going to see a simple, the simulation in its infancy. We're going to have 2 types of actors. A stock, which whenever it receives a tick message, it's going to change its price by some random amount. And I have some code just to randomize some stock changes just so we can see the values changing over time. When it receives a get price message, that's somebody asking, another actor asking, hey, what's your current price? It's going to respond with that price in a price message. And we're going to have our system send these tick messages at regular intervals. So we'll just keep telling the stocks to tick, hey, change your price, just to simulate stocks changing price over time. A trader actor, a trader type, which is an actor, which is going to be aware of each ticker symbol and actor reference. It's going to get that information in a map in its constructor. So it knows about all the stocks. It knows that they exist and has references to their actors. So it can ask those stocks for their price. So these traders are going to take these actor references, send them the get price message, get the price of each stock, and then make decisions based on that. When it receives a check stocks message, which is going to get at regular intervals from the system, it's going to send this get price message to each actor, each ticker actor, stock actor, And when it receives a message back, it's going to get that price message and then make a decision of whether or not to buy that stock. The decisions are going to be made purely randomly. It's not going to look for good deals or best investments. There's nothing sophisticated going on in the code right now. I believe I do a 50-50 shot. I just flip a coin and say, are you going to buy this or not? And then a random quantity. So let's see how we can simulate this, how we can set up this simulation in the code. What am I doing here? Presentation. I am losing my mouse a lot today. I look at my mouse through my OBS window, but it's actually over here. So I don't look at my mouse directly, and then I lose track of which screen it's actually on. Am I hovering over ABS, or is my mouse over here and I can see it through OBS? In case you're wondering, I'm not completely blind. I just have two screens being displayed on a single monitor. I don't know. It's a weird setup, I guess. So let's take a look at the code, and I'm going to double check again to make sure I'm on the right IntelliJ. I only have one of them open, so it better be right. Just received your dividend from Apple. Nice. I should do more with stocks. So I kind of got scared away from stocks. I used to have a lot of examples in my classes, and I had a few students one semester really complain. They're like, this isn't a finance class, this is a computer science class. What the hell are you teaching us, and why are you doing all these finance examples? So I kind of overcorrected, and now I have almost none. I think this is the only one that shows up this semester. But I used to have tons of finance and finance homeworks, and I had a stock trading homework where you had to, given a series of trades, determine the final return on investment of all those trading decisions. And then the expansion objective was to write in a trading bot, an automated trader that can find the optimal trades to make given historic stock prices. So looking back on history, what would be the optimal trades that you could have made, which I thought was a really fun homework. Maybe I'll bring that one back sometime. And use it. Oh, we could use a genetic algorithm to find the best trades. Oh, man. That could get good. Start combining the homeworks. So let's start with the stock market class. This is going to set up the actor system and add our actors to it. So I'm going to set up my system, create a couple of stocks. For this, we're going to trade Google and Amazon and give them some initial prices, which were the prices. If you're really insane, you can figure out which day I actually made this example, which I wrote this example, because these were the actual prices at the exact time that I was making this example. These were the prices, I believe. Anyway, I'm quite certain that's what I ended up doing here. So Google and Amazon, these were their prices. So we're going to give those as their initial prices in their constructor. So the stock class takes a string as its ticker symbol and a double as its initial price. So we're going to give it a string for its ticker symbol and a double for its initial price. And that will initialize, set up these actors, and return references to these actors. So I have these two actor refs, one for the Google stock and one for Amazon stock. I'm going to set up two traders here. Actually, I'm going to set up one trader here. Oops. Seriously, this is the one thing my brain struggles with the most. Is constantly switching between Mac and Windows, and my keyboard shortcuts are different in each. My brain just can't adjust. I just can't understand it. It's like, no, you hit Alt here. No, it's Control on Windows. So I'm going to set up a trader. A trader wants to know about all the stocks that it can trade, and it wants that as a map of actor ref to string, which is the actor for that ticker for that stock, and the symbol for that stock, the ticker symbol for that stock. So that's what the trader wants in its constructor. So we're going to create that map. We're going to create our references to the ticker symbol, reference actor ref to ticker symbol, and give that map of stocks to the trader that we're creating. And we're using this props class of trader syntax again, and giving it that map of stocks in its constructor. You should have a method to bet against the stocks. Oh, with option. Oh my goodness, we could go really far with a homework like that. Coding options and in shorts. And, oh my goodness, it could be a good one. There's a lot of meat there that we could dive into, where there could be a lot of expansion objectives. And yeah, GA is a super homework. I kind of like that, where I want that to be physics engine as well. I want physics engine to keep reoccurring. I did that one semester, but then I had the complaints from students where, which are legitimate. When I say complaints by students, these are legitimate complaints, obviously because I reacted to them. So I do think they're legitimate. Is that they never took physics before, and then they're kind of lost. This is one big advantage of genetic algorithm, is none of you have done genetic algorithm before. The playing field is level because none of you have seen it before. But some of you took high school physics and know what vectors are. Some of you haven't. Some of you have taken college physics by now. Some of you haven't. So just knowing what a vector is a huge advantage for the physics engine. And then for finance, if you've taken any finance class or you followed the markets at all, you have an advantage on that one. So I don't really like those assignments where certain subsets of the population of the students have an advantage over others just because of their background. I think the same thing for games as well. Some people haven't played games, and that one I struggle a bit more with because it can be a big motivator if we're making games, which I did kind of tone that down too. Anyway, it's not what we're here to talk about. So I'm going to create a trader, give it the stocks, and then set them off, let them do their thing. So I'm going to use this scheduler like we did before, making sure I import the dispatcher, or else scheduler doesn't work. If I comment this out, I get errors all over the place. If I comment this in, I'm going to be fine. Again, I won't require you to ever set up a dispatcher and set up schedules like this. I won't have you do this, so that's not something you strictly have to remember, but it's something nice to know if you're doing anything outside of these assignments. It's something you got to know. So I'm going to set up the scheduler, and I'm going to send the tick message to each of our stocks immediately and also every second. So this is the time, the delay before sending the first message, and this is the interval of when to send. Oops. Oh my goodness. Brain, work with me. The initial delay, and then the interval of how often to send this message after the first one is sent, and the actor message that the actor ref that we're going to send that message to, and finally the message that we're going to send. So we're going to keep sending the tick message. Oh, that's worth looking at the code too, where we can actually see that receiver. We're sending that message to that receiver every time we're running this first order function. Oops, that's actually a method. This is an anonymous class. So the runnable, is it worth going down this rabbit hole? Is we need to implement this run method. This is actually Java code, but interface is the same as trait in Scala. So we're creating that and then overriding the run method, implementing the run method right in line without actually extending the runnable class for what it's worth. Implementing run to send this message, and then sending that every interval. No, I'm not going down this rabbit hole anymore. So that's what we're doing. We're waiting this initial delay to send the message once, and then sending that message after this duration until forever. So send it immediately and every second. For the trader, we're going to send it the check stocks message. We're going to wait half a second before sending this message the first time. What's up, Trino? And then send that message every second thereafter. And so every second, the stocks are ticking. And also every second, but staggered by half a second, we're going to tell the trader to check the stocks. So we're making sure that the stocks tick, then the trader checks the stocks tick, then the trader checks the stocks, and so on and so forth. If I had this is also 0, the trader is going to sometimes be checking stocks as they're ticking or in the middle of a tick and things like that. So I just want to stagger those checks to make sure we get some crisp behavior out of this thing. Rip maze solver. Alright, so when stocks receive a tick message, we're going to set up our same actor structure where the stock class extends actor, so we get all the behavior of an actor. Since we extend actor, we have to implement the receive method, and I didn't show this last time, but if we don't, we have a contract with the actor class that says, hey, you're going to implement that receive method, right? So we have to implement that to get rid of the errors. And since I already went into the library once, let's do it one more time. We do have this actor.receive. It's not as clear as I want it to be based on how we've seen it in class. There it is. So receive, which doesn't have any implementation. There's no equal here. This is not implemented, so it's abstract. So we do have to implement that if we're going to extend the actor class. So we implement we implement receive, which is going to use this match case syntax. And for each type of message we receive, we're going to define the behavior that an actor of this type should have in response to that message. So if we receive a message of type tick, I should show my messages. If I receive a message of type tick, which is a case object, or a message of type get price, which is also a case object, we're going to react appropriately. On a tick, I'm going to randomly adjust the price of the stock by up to 5%. So I have a random value. I'm going to subtract. Is it worth going through this? Yeah, we got some time. So math.random gives us a random value from 0 to 1.0. Actually, you've all been through genetic algorithm. You know how randomness works by now in code. So I'll go through this quickly. But this gives us a value from 0 to 1. I'm going to subtract 0.5 from it. So now I'm shifting my range from -5 to +5 is my new range. I'm going to multiply that by 2. So now I have the range -1 to 1. And then multiply that by my percent change. So 0.5. 0.05%. It's 0.05, I should say, not necessarily percent, but 5%. So now, after all this, I have a value between -0.5 and positive 0.5. So anywhere from a -5 to a positive 5% change in the stock price. I'm going to add 1 to that, so now I have between 0.95 and 1.05. And I'm going to multiply the price by that value. So depending on what this random value is, I have anything from a 5% decrease to a 5% increase in my stock price. And I'm just going to print what the price is to 2 decimal places. I could have used formatting. You've seen in the past I used format strings to do this. Here I ended up rounding the price manually. Kind of the same effect to get a visual without all the double truncation mess that you can see sometimes. What's the command on Mac to comment out code like that? Command, I'm so lost, got you there. Command /. And then in Windows, it's Control /. But the reason I have so much issue with this is I swapped my Control and Alt keys on my Windows machine. So it behaves more like the Mac machine if you don't look at the actual text, because Alt is where Command is on Mac. But I don't think that works all the time, or I don't know, something's confusing about it. But anyway, and then so this just updates the price. It changes the internal state. Price is a variable, and we change the value of this price. But we didn't respond. We didn't send any information to anybody. So we also need some way for other actors to get this information. If the state just changes inside this actor, nobody can tell what that information is. You can't just go to an actor and read its variable. Everything has to be done through message passing. So we're going to send, if we want to know the stock's price, we're going to send the message get price. And it's going to send back to the sender the price in a case class of type price, which takes one double containing that actual price and sends that back. I didn't mention this explicitly. I'm sure you caught on by now, but the case classes, we don't use the keyword new. We don't use that. This should be new is unneeded. I don't know if it's unneeded or if it actually breaks things, but anyway, you shouldn't have it. You don't need it regardless. That's one extra benefit of using case classes. For what it's worth, we don't use the keyword new. I don't know if that's a benefit or not, but it's a feature. So that's our stock class. This is how a stock is going to get some initial price, and every time it gets a tick, it's going to make up to 5% change in that stock and that price, and people can ask it its price, and it'll send that price back, whatever the current price is. So that's what's going to happen here. We're going to send every second the tick message. Each one of these stocks is going to change this price by 5. And whenever we ask for its price, we're going to get that price back. The last step is the trader. How does a trader behave? Pretty randomly. This is an irrational trader who's going to probably lose a lot of money in the actual markets. We know about each actor. We have references so we can send messages to their actor refs. And the ticker symbol, just for when we print things out, we're going to be able to print them out with the ticker symbol and not the actor ref, because the actor ref is unreadable, really. And we want to keep track of a few things. We're going to start with some currency, $100,000 in this case. And we're going to track the stocks owned with a map of strings to int, which is ticker symbol, to the number of shares owned of that stock. Yeah, that's what I'm thinking. Since it was grayed out, I think the keyword new wasn't really doing anything, because usually that means this isn't doing anything. But I would have to investigate a little bit to make sure that's completely true. I don't do it here. Like if I said new map here. Okay, maybe it is completely true for... Yeah, because I thought it would break things. But the way case classes behave, it must just ignore it. And I was expecting that keyword new to break things with the case class, but just the way case classes work, it must be something internal that says keyword new is fine, just doesn't do anything. So I'm initializing this. I'm going to say for each. We'll do a little review of the yield keyword. For each ticker in stocks.values, so I'm going to get all the values out of this map, which are all the ticker symbols. I'm going to iterate over all those ticker symbols and create a new data structure containing all of the key value pairs mapping that ticker symbol to 0. That's going to give me a data structure which is going to be a sequence of pairs? I don't know what it would be. It's going to be something that I don't want, and I'm going to slap a 2 map on that to make sure it's a map, because that's what I actually want it to be, because I want to work with maps. Create a map and store it in this stocks owned variable. So I wanted to flash back some functional programming and show you how we can create this map and initialize it to owning 0 of each stock. Of course, there are many other ways to do this. This is just the way I chose, because that's the way, I felt like doing it when I wrote it. But there are other ways. I'm sure if you did the same thing, you'd come up with something else. And it's perfectly fine. So whenever we get the check stocks message, I'm just going to do some printing out. This is where I'm going to print out just the current state of things so we can actually watch things happening. That's one thing with concurrent code. It gets a bit more difficult to visualize what's happening. So I want to print things out at some point. I chose to do it when I receive the check stocks, because if I do it anywhere else, I'm going to get things printed out multiple times. So check stocks. So once a second, we're going to print out the state of everything, how much cash we have, how many of each stock we own. And then we're going to do the actual, actually do something, is send each stock the get price message. Again, some more functional programming. We know functional programming now, so we get to use it in our daily lives. Our stocks, the keys of the stocks, which are all the actor references. For each of those, since we don't need any return value, we're not concerned about the return value here, we can actually use for each for the side effect of sending a message. For each stock, I'm going to use the wildcard here. so I'm not naming my variables. We could also do, just recall that we could also do stock of type actorref, big arrow, stock. We can do this. This is the same thing, does the same exact thing. But if we only use the input variable, the input parameter once, we can actually shorten that, save ourselves some typing, and replace all that with an underscore. And this will be interpreted as the input parameter. Whatever that value is, we're not going to name it. It's an anonymous variable. And whatever it is, send it the get price message. So for each stock actor reference, send it the get price message. So quite a bit going on in one line. That's one feature of functional programming. We usually really compact our code and get our code more descriptive and expressive. For each stock, send the get price message. Instead of explaining how to do something, we're just explaining what we're doing. We're sending each stock the get price message. And it's all valid code and it all works the way we want it to work. So yeah, it has why Wi-Fi. So the last question I have is why it works there but not for maps. So map also has an apply method, but why can't I say new map? But why can I say, like, why doesn't that automatically go to the maps apply method? Where if I say new price, it seems like this does go, oh yeah, it's defined in my code. That does go to, it does seem like that's going to go to the prices apply method. But when I say new map, it doesn't go to the maps apply method. It actually tries to go back to the maps constructor instead of the apply. That's what I'm still wondering on that one. So that must just be a feature of case classes, that new automatically goes to the apply. Maybe I know the answer to that. Do I know? I would just be guessing if I tried to give an answer. Can you explain get or else sender on line 17? Yeah, I'm getting there. Patience, Ellipsio. When your variable isn't variable enough, underscore. Blame Java. It's fun blaming. I used to blame Java for a lot more when I was teaching in Java. There's a lot to blame Java on. Scala, I think, is a much more, I don't know. I find I blame Scala less than I used to blame Java. And finally, when we receive the price, so we asked each stock, what's your price? When we get those prices back, that's when we're going to make our trading decisions. Price is a case class. So when we receive a case class, we can use this syntax, just like it's a parameter to a method. We're going to use this syntax, give that object of the type price, of the type of the class, a name, which can be anything we want. I can call this, something else, but then I have to change it everywhere, which I'm not going to do. But this is whatever I want it to be. It's just the name of the variable you're creating, and that variable is of type price. So if I receive a message of type price, this is the code that's going to be executed. And it's going to be executed with a variable named P of type price, of that type price. So for each stock, we're going to get Oh, yeah, this line doesn't really have to be here. I'm still going to explain it, but yeah, that one caught me off guard a little bit, Ellipsio. Yeah, you're good for asking that. So this, I'm going to get the ticker symbol from the sender. So I'm going to say, whoever sent me this price, give me the ticker symbol for that sender. So sender is an actor ref, and I'm going to look up that actor ref. I'm going to look up that actor ref in my map of stocks. If it's not in that map of stocks, so if this is a stock that I don't know about, then I want to not try to purchase any of that. So this doesn't really have to be here as long as we're careful about making sure we're only sending the get price message to stocks that we know about. But if there happens to be a third stock in here that we don't know about, which happened to send us a price message, this is going to be a failsafe against that. So I'm going to check to make sure that I know about that. Get or else is going to get a value out of a map, add a key. So I'm going to try to get the value at this sender, at this actor ref. If this sender is not in the map, we're going to get the else. The else is my second argument here, which is empty string. So either get the value for this sender, that ticker symbol, or else return empty string if this actor ref is not a key in the map. So this is either one of my ticker symbols, my valid ticker symbols, or it's the empty string. Yeah, you're right to be confused on that one, Ellipsia. I'll still stand by my patience comment, but yeah, that's a good question. Solid question. So if the ticker is not the empty string, that means this sender is a known sender. We know about them. This is a stock that's in our knowledge, in our database. So we're going to execute a trade, potentially. And this is just purely random trading. This is where all of your actual algorithms would go to decide whether or not to buy or sell or whatever. I'm just going to say there's a 10% chance that I'm going to purchase. If I'm going to purchase, I'm going to purchase between 1 and 10 shares. I guess 1 and 9 shares. I don't know if 10 would ever actually hit, would it? This would have to be exactly 1.0, which might even be impossible. And just in case this gave me 0, if math.random was less than 0.1, I'm going to at least purchase 1 share, so I'm not trying to buy 0 shares. That'd be silly. So I get a random quantity, 1 to 9. And then I'm going to decrease my currency and increase my shares owned appropriately, as long as I can afford that purchase. If I can afford that purchase, I'm going to make that purchase. Price times quantity, this one I want to explain. Getting the price from the price, so P is of type price, which has a variable named price. That word's going to lose meaning too now. Times that by the quantity and subtract that from my current currency. And why wouldn't I put this right here? Be consistent, Jesse. Well, I missed the keyword this in a lot of places. And then update the stocks owned. So for this ticker symbol, retrieve from this map, which this is the same as saying .get. Retrieve from this map the value. Oh yeah, and then I'd have to do get, right? And then it tells me to undo that and go back to what I was already doing. And so this is going to get the quantity owned of this ticker symbol. So I'm looking in this map. I'm getting the value at this key. So give me the int of how many of these I own. Add to that the new quantity that I just purchased. So this will be the new number of shares owned for this. And I want to create a key value pair of this ticker symbol to that quantity that I now own of that ticker symbol, and then add that key value pair into the map. So this will effectively, since I already have a key value pair in this map with this ticker symbol as a key, this will effectively replace that old key value pair with this new key value pair that I'm adding, since we can't have duplicate keys. So it's going to replace that old one. Come on, give it to me. Then we can run this thing. Compiling. This is a class or something. What's up, another CS student? And we're learning about Scala actors right now. And we're about to see our very simple simulated stock trading. So if we look at this, oops, I wanted to make one change here. I made this change and then didn't push it to the repo. I just want to add a new line so the output looks a little cleaner. All right, so we can see we have our initial stock prices. We send the first ticks message to Google and Amazon, and we get some random changes in their prices. Google went down, Amazon went up for what it's worth. We still have all of our initial state for our $100,000 and no shares owned. And this is a community college. And then we can watch things change. Remember, this trader has a 10% chance of purchasing either one of these shares each round. So it'll take a little bit, the next one actually, to be able to actually get a purchase. So here we see that we had a purchase. We hit this. We hit our 10% chance on Google. This ended up becoming 8. So we randomly purchased 8 shares of Google and updated all of our map and currency based on that transaction. Then we kept going. The prices are changing. Well, Amazon, we can see the order changing. So Amazon, each stock is reporting its own price. So Amazon happened to get the message before Google on that tick. We know that that's ambiguous because we told them to go at the same time. Everything's the same. And Amazon happens to be ahead of Google for that tick. A good demonstration of how we can't rely on the order of things if we're not very careful about how we're controlling time. What happened if this was really connected to the stock market? I mean, we can do that. We have the power to do that. We can access an API that tells us current stock prices and then have our algorithmic traders make our trades for us. And yeah, we'd lose a ton of money, of course. But that's within your power right now, by the way. You have enough programming knowledge to do that, to hook into the actual stock market and make algorithmic trades and lose all your money. You can do that through software if you're having trouble getting rid of all your money. And here we see we had another trade. We bought one more share of Google. And we can see this thing keep going. We're up to 17 shares of Google, 32 of Amazon. We can see the prices keep changing. We can sit here and watch the stock market all day. We're out of money here, it looks like. Not out of money, but we can't afford a share of either one of these. So we're never going to execute another trade. We're just going to be able to watch the stocks change, fluctuate. Actually, it's possible for one of these stocks to tank below 90, and we could purchase another one. And I'll let it go just in case that gets to happen at some point. All right, any last questions on that one? Anyone want to sacrifice their money? Count me out. I think it would be fun in this class to have, like, if I set up a server with a simulated stock market that just ran all semester and you could interact with it. You could write software to interact with it throughout. I could set you all up with accounts that start with some initial funds, and then you can just write software to play around with it. We can sit here and watch the stock market every day. Don't get sucked into that. I got sucked into that once. I was watching the markets all the time. During the 2008 crash, it was super interesting. There's a lot happening. I got sucked in. Yeah, whoever has the most funds at the end of the semester gets an A. I think it'd be fun. I can't quite have your grade depend on randomness, but just writing software to interact with it, you're going to be learning. As long as you execute, a bunch of trades, I can give you a grade for that or something. There's a way to make that work. Everyone who gets an A becomes Jesse Twitchman. Maybe there could be some reward for whoever has the most funds at the end of the semester. But I have to keep in mind that it's random, so I can't have it be a grade. But yeah, whoever has the most funds, the top 3 funds at the end of the semester get Twitch VIP status or something. But Analyze the chart patterns. Now I could actually have the simulation follow certain patterns instead of being purely random. And then I could actually maybe reward you for having the most money at the end. If you analyze all the patterns and see which stock is going to grow. Yeah, there would have to be a leaderboard. It just can't be attached to your grade directly unless I don't know. I can't have randomness in your grade. It's not okay. All right, so let's take a look at the other. Oh my goodness, we only have 4 minutes. I had spent way longer than that than I thought. So I'm going to rip through this one pretty quick. There's a lot here. I can't do it justice in 5 minutes, but I at least want to talk about it. So for this one, we're going to have simulate traffic and traffic patterns between intersections and cars. Our two actor types, the intersections, are always going to be a north-south road intersecting with an east-west road. Initially, we have a green light on the east-west road, and the green light alternates at regular intervals. So we're going to say it's green east-west, then it's green north-south, then it's green east-west, etc. You know what intersections are. And then cars, which are going to have a list of directions to follow, which are the intersections that it's going to go through. So we don't have like a geography mapped out. There's no physical space that this simulation acts in, at least not yet. That's another one I would like to build out. But they all have a list of directions to follow, which is a list of intersections that it's going to go through. So it already went to Google Maps. It's got its intersections, and it said, go to this intersection, this intersection, this intersection. And it knows whether it's approaching each intersection from either east-west or north-south. Each time it arrives at an intersection, it has to ask that intersection if it's a green light or a red light. If it's a red light, stop until the intersection says green light. And then once it's green light, go on to the next direction. Which I mentioned. And this is the big one that you need for your lecture question. Is that we have messages that need to be delayed. So we have to wait a certain amount of time and then send a message. This is similar to how we're scheduling intervals of messages, but a little bit different. We're going to do this from inside an actor. We're going to import its dispatcher from the context. Context is going to allow you to access the actor system that an actor ref is attached to. So from that context, we're going to access that system and schedule a message on a delay. The actor ref that you're sending it to, if this actor, in this case, sending it to itself after the delay, we can use self. This is a variable in the actor ref class, which is going to be a reference to its own actor ref. And then the message you want to send to it. Using context, I think I have a slide on this, right? Yeah. With context, this is something you have to do in the clicker homework, so I got to mention this too. Get this out there. The context can also be used as the system to add new actors to a system. So if you have an actor that needs to add another actor to the system, use the context and the same syntax you use from the system, actor of, props, class of, and any constructor parameters, any constructor arguments that you want over here. Same syntax. So if an actor needs to add another actor to the class, do that through the context. But back to dispatcher, back to the scheduler, we have the delay of the time, the recipient of the message, and the message to be sent. So very similar to the syntax of our intervals, our messages that go in intervals, but we're sending only one message and not multiple messages. All right, let's stop the stock market. And let's quickly see the traffic example. So we're going to set up 4 intersections. Each intersection has a time interval of when it's going to switch green light and red light. We're going to set up the directions for each car, which has a delay. This is the amount of time it takes to travel to this intersection. And true or false, whether it's going east, west, or north, south, where it's approaching the intersection from. We're going to set up some cars that follow this route. We're going to set up another route and another car that's going to follow route 2. So 3 cars on route 1, 1 car on route 2. Each intersection starts with a red light on east-west. And whenever it needs to change the light, it's going to swap that between east-west and north-south, what the green light is. And any cars who are waiting at that intersection, I should actually explain this one first. When a car approaches an intersection, it's going to tell that intersection whether it's approaching from the north-south direction or the east-west direction. If it's green in that direction, it's going to tell that car, hey, you have a green light, just go. If it's red in that direction, it's going to keep track of all the cars that are waiting for that red light. And then when we get the green light, when the light changes, we're going to send a green light message to all the cars who are waiting in that direction, who are waiting for that green light to be able to go. So we're communicating through these messages. The traffic light is sending the message to the driver of these cars. Hey, it's green, you can go now, and then they can go off to the next intersection. Each time the light changes, we're going to use this delayed message. We're going to wait the time interval, the time between light changes. After that amount of time, we're going to send ourselves the message to change light. So each time we receive a change light, we're changing the light, waiting time interval, and then changing the light again. So you can kind of, in a way, think of this as an infinite recursion, where we have this light just forever changing between which direction is red and green. A car gets a list of directions. Those directions contain the intersection, the time it's going to take to reach that intersection, and whether we're going east-west or north-south to get that intersection. So each time we receive a direction message, which we're going to initially do, we're going to immediately, once a car exists, it's going to send itself the first direction in its list. When it receives a direction, that means, hey, this is where we need to be going. We're going to wait the time duration of that direction, how long it takes to get to that next intersection. And after that delay, send ourselves what we call an approaching message, which tells us, hey, we've arrived at this intersection, or at least we're approaching it, and we need to know if this is green or red, do we go or stop? When we get the approaching message, we're going to send the appropriate east, west, or north, south message to the intersection that we're approaching. The intersection gets this message that we saw before and says, well, if it's red, I'm going to add you to a list and not tell you anything. If it's green, I'm going to send you the green light message right away. If you got put in this waiting list, once the light changes, then I'm going to send you the green light along with everyone else who's waiting. So once we get the green light, we're going to remove the first direction from our list of directions. .tail is the same as .next. If you recall, the same as .next in our linked list implementation. So directions equals directions.tail effectively removes the first direction. We've already completed that one. We're on to the next one. If there's no more directions to follow, we've arrived at our destination. We could have some print line that says, yay, you've got here. You've arrived at your destination. If it's not empty, we're going to send ourselves the next direction, just like we did when we first started. We're going to send the next direction in the list to ourselves and keep moving down that path. If we run this, we can watch our cars through text anyway. Travel through this system. Not very readable, admittedly. And to test something like this, create a few intersections and a route like we did before. Create a car to follow that route. And as soon as we create that car, it's going to start driving that route. And we can ask it, get next direction. The one thing I didn't mention. Get next direction is just saying, hey, where are you headed? Asking a car where it's headed, and it's going to tell us where it's headed by returning the first direction in its direction list, or it's going to tell us that it's arrived at its destination. So we're going to use that for testing. We're going to say, hey, get direction, receive that direction. We're going to expect that message in response. Get that direction and make sure it has the values that we expect. Make sure it's headed where we expect it to. We're going to wait, get the direction, make sure that direction is what we expect. Wait, get direction, make sure that direction is what we expect. Wait, get the direction, make sure that direction is what we expect. So for this question, for testing something like this, I highly recommend, and I highly recommend you do this for Clicker, is draw out exactly what you expect to be happening at what particular time. So I keep track of my time, how many milliseconds have elapsed, and I keep track of where the car is at each point in time and when its directions are expected to change. I would do the same thing as you're clicking, as you're purchasing equipment, as you're waiting. Keep track of what your gold is expected to be and keep checking that gold throughout the process, or at the very least at the end, make sure it's the appropriate value. And this is another one that could be a fully fledged homework. If I can get the visuals and actually watch the cars moving between intersections, oh man, this could be a cool one too. All right, that's officially the end of lecture. I don't have the print statement to say. This is just the lights going. I don't have anything to say arrived at our destination. I should have that print line in. Stop that because those lights will go forever. And last semester's lecture question for this was to add detours to that traffic. So if I were to bet, and going off of last semester, and especially since I ripped through this so fast, you probably didn't quite follow most of what's happened with the intersection. It would take you a while to sit down, stare at this, and really think it through to see exactly how this traffic simulator is functioning and how all the messages are being passed. Much less giving you a lecture question that says, add detours to this, where an intersection would get a detour, which would say any cars that approach this intersection, tell those cars to update their list of directions to follow this detour because you can't pass through this intersection. And then the cars would have to follow the detour appropriately. It's not, like, the solution isn't too complex, but figuring out how the hell to do something like that. And I gave very little instruction, or very little guidance, I should say, where I'm just like, go do it. Do it however you want. And as long as the directions were, my testing just checked the directions were what they expected to be. It was a tough one. It was a tough lecture question. Oh, Mango, I miss good luck on you. Good luck, though. Hopefully you studied up. Right, autopilot. I mean, it basically is. Well, it's at least GPS right now, what we have. Well, maybe not. But this could easily be combined with Maze Solver. If Maze Solver turned into a traffic homework and had two parts, one for the maze solving, which would be computing directions, and then one for all the messages that are passed between the different actors. But this is certainly the point of the. I shouldn't say that. This is one of those points of the semester where the code, the programs that we're building, are getting pretty cumbersome. Like there's a lot of moving pieces now. Like literally, a lot of messages being passed now, and it's a whole new way of thinking. So things start getting. It's another degree of difficulty. It's another way of thinking. TA says we have easier homework and lecture question than they were, like when they took the class. I'd push back a little. Ask them how many free lecture questions they had when the TAs, most of the TAs anyway, when they took the class. How many of the lecture questions were literally free? And they'll shut up. They won't be bragging anymore. Some of the homeworks they had were quite a bit more difficult. They also had partial credit on them. It wasn't this pass fail system. If they wanted full credit in every single point in the course and complete everything and max out, it was definitely harder to do. But to get an A, even, or a decent grade, if you're aiming for a B, they could just do the first few objectives of each homework and be just fine. Very different course structure. Very different grading structure from what you have. So I had to make, since the homeworks are all or nothing now, I had to make the homeworks easier, in all fairness. Like, I couldn't keep them at the same difficulty and say, do or die. Good luck. I can't do that. I had to soften them up a bit. Because before, like, the primary objective was only 20 points out of 100. So if you got all but the primary, you were in pretty good shape. And then you do all your lecture questions, you can still get an A. But now when I say, if you don't get the primary on one homework, you can't get an A anymore. You have to get all the primaries. The homeworks got easier to reflect that. And then what would be the harder part, that would be your last 20%, that became the expansion objectives. Roughly speaking. I mean, I rearranged a lot of stuff, but roughly speaking, that's what's up. In the stock programming for this semester, what I use, I mean, whatever one I can find the easiest API for. So the problem with stock APIs is there's a lot of money involved, so they usually want money for the API, for access to the API. So I'd probably create my own just simulated stock exchange instead of trying to get real data. Real data would be cooler, but it's a lot tougher. You can get 15-minute delayed data, but even there, I don't know of a public API anymore. There used to be the Yahoo API, and I would use that. I've used that for assignments even, but they've since shut that down. So I'm not aware of a free public API that, even with a 15-minute or even a 1-day delay, like I don't need anything too accurate. I don't need current, like right now prices, which are crazy expensive to get access to those. But I'm still not aware of an API. There's probably one out there if I look deeper. The nice thing about the Yahoo one is it didn't require an API key, which was a big deal. So if I tell everybody in the class that you have to get an API key, that wouldn't be the worst thing. Maybe we could do it that way. Maybe it's just Survivor by... Oh, for the TAs saying they had it easier. Or that you have it easier. I don't know. The TAs are also a lot more experienced than they were when they took the course, so everything probably looks a lot easier. Is also going to be a factor in that. Yeah, it's definitely apples to oranges, though. Your head hurts from May Solver. Haven't you been saying that every day, every lecture for the past few weeks that it's making your head hurt? You might just have headaches. I mean, you can't always blame it on 116. I mean, you can, and it probably is the cause, but you think maze is harder than genetic algorithm, really? I thought maze was way easier. Converting the map, that list of lists, into a graph, that's kind of tricky, but I believe that's the only tricky part. Like running breadth first search, since I give you the breadth first search algorithm and I go through lecture exactly what you have to do, I don't think that part's very difficult. And then finding the velocity, that can get a little tricky. But not too bad, since I kind of gave away how to do that one as well. Remove another homework that is harder than Maze Solver. remove. Why am I like event-based architecture? Event-based architecture is definitely the hardest one. The hardest learning objective. As I've said a few times now, I do go a bit easy on the assignments. Like I could, it's easy to get out of hand. Like the lecture question that I mentioned with detours and the traffic example. It's easy for things to get out of hand and get difficult very fast. If I'm really nailing down and asking you to write programs taking advantage of event-based architectures, but I don't really do that. Most of the time, actually I think all of the time, I ask you, like I don't ask you to architect a program with event-based architectures, but I say make an actor that responds to these messages by doing these things. So with these messages have this behavior. So I'm doing the design and the architecting for you, and then I'm expecting you to be able to contribute some code to a program that already implements an event-based architecture. So it's definitely the hardest chapter, but I don't think it's, from what I ask you to actually do in this learning objective, I don't think it's the hardest part of the course. I don't think the assignments are the hardest part of the course. I mean, maybe they are. I don't know what I would say was the hardest part. I think the intent is that the difficulty peaks at genetic algorithm, but I'm getting mixed messages on that, whether that's true or not, based on some maze solver questions that I just saw. I think Google has their API that's free. Now, as I was saying that, I think they do, and you have to get an API key. But maybe that's worth doing. Maybe next semester I can say, hey, go get an API key from Google and set up a thing. I mean, that's useful in its own right, knowing how to set up API access. LO4 is a nice transition from LO3. That's good to hear. I think LO4 should be a little bit toned down from LO3. I don't believe in a difficulty curve that's just continuously going up throughout the whole semester. I feel like most classes I've taken follow. I like having some ups and downs. Give you some intense challenge, and then give you a little bit of a break. Never a full break, but there are ups and downs. And even then, I don't know if I am hitting that this semester. It should be for each learning objective. The first few lectures of each learning objective should be pretty chill. I don't know if it feels like that, though, because you're always trying to catch up. But it's definitely LO 1, 2, and 3. It keeps getting more and more difficult, I think. LO 4 is a dip down, and then LO 3 comes back up, or LO 5 comes back up a little bit. And then the rest of the semester after LO 5 is just a steep drop off in difficulty as you're just catching up on everything else. The content is tricky in the last week and the next week, the week after break. But I don't test you on it. I don't really ask you to do much with it. It's more of just explaining the rest of the things that we haven't explained that are in some of the homework handouts and the project contribution that you'll see. TradingView has a free API. Just laughs at my misery. I don't want to. I don't mean to. We're not going over GUIs, are we? I want to still go over GUIs because I was going to go over it during catch-up week, and then I never did. So I plan to do that the week after break, where it just says MMO architecture for that whole week. I think I'll talk about GUIs as part of the MMO architecture, since I didn't yet. I'll basically treat that as an open week. It'll be all about MMO architecture, but it won't be what I usually do. I'll just do whatever I need to fill in all the gaps. And that's what that week is intended to be anyway, is you can build an MMO with what you know now, and anything that we missed, like GUIs, databases, I forget what else, but anything that's missing we'll do. And most of what we're missing comes next week with WebSockets. I'm so lost. Good luck on 199 recitation, encryption. Whoop, whoop. Oh, it's a full week for 116 anyway. I've had that on the schedule where it's only fair, I think. Lecture and lab canceled Monday through Friday. For 116, the university, I only canceled, I don't know how many days. I didn't even pay attention. But since they took away our Labor Day, I said, well, I'm going to cancel Monday then. If you're not going to give us Labor Day, uh, we all need a break, myself included. We all need to take a break. Already took one break away from us. They're taking spring break away from us next semester. Uh, like, we need a break. We can't 14 weeks straight going through a semester. I don't know how we're going to survive next semester. I always need those breaks to catch up, especially spring break. It's always nice having that break right in the middle. Sorry, struggling through life. Did I break that news to you? Spoilers. It's gone.